Thanks for joining us at the 2025 Zero Emission Fleets Reconnect Conference. These conference presentations are proudly brought to you by Plug-in BC.
We're really excited to bring our first group of panelists to the Reconnect stage to discuss implementing zero-emission medium and heavy-duty fleets in waste management and transport. I'd like to welcome the moderator of this panel, Charlotte Argue. Charlotte, here you are. Senior Manager, Sustainable Mobility at ZEF, to the stage to welcome the panel and session. And we have almost an hour for this particular session, so hopefully we'll enjoy it. Thanks very much, Charlotte. Welcome, Kay.
Again, I'm Charlotte Argue. I'm Senior Manager of Sustainable Mobility for ZEF. Rob, thanks for the shout out earlier in your remarks. ZEF is a connected vehicle company, so we do telematics. We're Canadian headquartered, but we have 4.7 million vehicles that are connected to ZEF around the world. So we're global in presence, and my role there is to look at how we can leverage vehicle data and vehicle data insights to help inform and advance fleet electrification in the industry. And so we do that looking at how existing vehicles are being used, and then we do that by looking at how EVs are performing today. And the types of fleets that we work with is everything large and small. And the medium and heavy duty industry and sector itself is quite interesting because I find that there's a lot of misconceptions out there around how and where electrification might work in that space. And a lot of these misconceptions is related to, the abilities or the performance or the capabilities of EVs. And to be fair, it's changed a lot over the years, and it's hard to keep up with the latest technology and the latest information. And to put that in perspective, I've been in this space for over 15 years now. And when EVs first kind of took off, it was really focused on light-duty passenger vehicles. Think, oh, this would be perfect for your second family car if you're just using it for commuting. Or in the fleet space, well, this is great for a pool car vehicle that's just going from meetings to meetings. And then over time, the suitability of EV technology started to grow and expand. And so we went from really focusing on that light-duty sector to starting to see the larger trucks become realistic and become feasible. And now many of our customers have deployed and are driving around fully electric trucks on the roads. And I think a lot of that change in terms of misconceptions hasn't quite caught up in terms of what people understand about that technology. And the space that we're in today, it's still an emerging market, and we've learned a lot from the light-duty passenger vehicle side to understand, how might this work in the medium and heavy-duty space. However, there's a lot of unique challenges in this space that fleets face in order to make it work, that you can't really do an apples-to-apples comparison from light-duty to heavy-duty. So for example, with heavy-duty and large deployments, we're looking at much bigger batteries. We're looking at much higher capital cost. The power requirements for the charging is often higher. The type of training and the type of change management is different and usually requires additional investment. And the cost of risk if something goes wrong is exponential compared to a fleet bringing in a light-duty passenger vehicle. And so with that said, there's still growing pains in the industry. But as I mentioned, we are seeing these vehicles and fleet operators figuring this out and applying it and learning from their deployments. And so I think, there's a big opportunity that we as an industry need to do, which is to share the stories of these deployments and learn from the challenges, learn from the mistakes, learn from the lessons, and shine a spotlight on those fleets who are actually deploying these vehicles today so that we can move those misconceptions up to catch up to where the technology is. And so that's what this panel is all about. So we have 4 different organizations and companies who have deployed EVs in their fleets, and we're going to hear from them on their challenges and their experiences and successes. And we'll hear good, bad, and hopefully not too much of the ugly. But we'll start with Zachary. So if I may, and feel free to just stand during your time, but Zachary Chan, project manager of Emterra Environmental. So Zachary oversees many projects through US and Canada, including the Fast Charge program in Cumberland, I understand. And he'll be sharing his story on EV refuse trucks.
Yeah, thank you, Charlotte. So I guess to start off, my name is Zachary from Emterra Environmental. We are part of a little bit of our company here. So we're a Canadian resource recovery company with about 50 years of experience. We're family operated and oriented. We got about 40 operational sites across Canada, whether it's processing material or collection fleets. I've got about 600 refuse vehicles in operation. About 30% of those are CNG, compressed natural gas, which is a low carbon emission fuel. We got about 1,000 employees across our organization, and our plants process about 500,000 metric tons of recyclables. A little bit of our green initiatives of history. Our owner, Emmy Leung, started with a blue bag program in BC, one of the first in 1980. And going forward, 2012, we initiated our first CNG fleet in Winnipeg. It's one of the largest of its kind at the time for extreme cold weather climates. We started our producer responsibility organization in Canada, RISE, in 2017. Then go to 2022 is when we kind of touched into the electric market, where we started to implement EV mobile equipment. That's our loaders, our forklifts. 2023, the next year, we started our first EV refuse vehicle up in Peel in Toronto. And then 1 year later, after seeing how it works, we figured, heck, why not try doing a whole fleet? So that's when we implemented our fleet in Cumberland in the Comox Valley. A little bit on that. It's a fleet of 8 trucks, Mack LREs. We put it into our existing processing material facility in Cumberland, BC. It's got 6 chargers, DC fast chargers, and we have the 8 trucks collecting at the moment. We started rolling these out in September, October, and they've been working fairly well since then. At the time, because we were operating the site at the same time, to be able to offset the power requirements for this, we put in a charger management system, which I'll talk a little bit on later, but that's sort of key in order to make this entire operation work with our facility. A little on the trucks, we have the Mack LRE chassis with the auto side loaders, 376 kilowatt hour batteries, the lithium ions. We get about 120 kilometers of operational range on them when we're actually collecting. And they are a zero emission GHG truck, so yeah, zero emission tailpipes. A few keynotes for what we found when we were running these trucks. Our first truck deployment in Peel in Ontario was pretty key. The first truck lets you iron out the kinks, kind of get your drivers and your operations to learn about these trucks, ease the worries, the battery anxiety and all the other features. Having Mack, which was the dealership, sort of work alongside us as we deploy these trucks was pretty helpful as well. Every time we had an issue, they're willing to come out, and if there's a truck issue, we could bring it back to the dealership, get it fixed. This is new technology, so there's always going to be hiccups along the way. As well as the effects of the cold weather, we found in Ontario when it went to extreme weather, say like -20 or so, you do have a bit of a decrease in your range as well as an increased time in your charging. And some of that can be attributed to the HVAC system in the truck. So when you get to the extreme weather temperatures, we had to moderate the temperature of the batteries so that they don't get too cold or too hot, and that can take power away from the battery as you're operating, as well as reduce and take power away as you're charging the truck. For regenerative braking, that's once the drivers got used to the truck, they could use the regenerative braking much more efficiently. And we found we can get something like 20% extra battery life. And when our trucks are coming back at 10 to 15% battery, that 20% is very important to be able to get us to the end of the day. Positive driver feedback. These trucks, EVs, compared to diesel or CNG, like the vibration is less, the noise is less, the fumes are less. If you if you ever ridden like on a propeller plane or the Harbor Air, the whole ride you're being hit with the vibrations, hit with the noise. If you go compared to like a Boeing plane on a huge one going across the country, it's a smoother ride. And these drivers, they're much more refreshed, much more not as worn down at the end of the day compared to diesel trucks. So once they're in there, they don't want to drive anything else. And power management system for our installation for the charging these things on our site. At Cumberland, we were already running a plant and putting in 6 chargers for heavy-duty Class 8 vehicles. It takes up a lot of power. And we didn't want to get a new site, and doing a power upgrade is costly and lengthy. So putting a power management system helped us use our existing power and manage where that power goes and when it goes so that we don't overdraw on the grid, so that we can charge these trucks at our existing site while we still operate our facility, which means that you don't have to go out there, get upgraded. It also helps BC Hydro as well, which they coordinated with us to be able to make sure this works. So coming up next, we're finalizing our national fleet assessment to see where else we have opportunities to decarbonize our company. Getting more hands-on experience with the low-emission vehicles, whether it's our mobile equipment or our on-road equipment, and just keep learning. So this fleet in Cumberland on Comox is new. We always have a couple issues come up, but the more you run them, the more you learn, and the more opportunities we'll find to implement them, whether here, Ontario, or everywhere else. So with that, thank you, and I'll pass it on to next.
Thanks, Zachary. I'll just quickly introduce next presenter. So Jay Jane is CEO of Moving Mountains Logistics, and he leads the largest commercial electric truck fleet in the interior of BC. So we're going to hear what's happening in Kamloops.
Thanks, Charlotte. That was certainly awesome, Zach. 6 medium heavy-duty garbage trucks, that's unheard of. That's amazing. So yeah, Moving Mountains Logistics. We're based out of Kamloops, British Columbia. I don't know how many of you realize this, but Kamloops is it's the most logical transportation hub for Western Canada for transporting goods out of Vancouver. And that's one challenge that's not been resolved yet in electrical mobility is electrifying line haul transportation between Lower Mainland and Kamloops, and then Kamloops distribution towards northern BC and Alberta as well. Our major limitation by far is the logbook hours. The current infrastructure available in terms of the battery size just makes it almost impossible to make it back in time to our depot. So I was actually quite excited to see that there's OEMs present here too, so I could share my thought on the battery architecture. 800 volt is the way to go. Anything less than 800 volt will never work for line haul transportation. The reason why you need 800 volt is that enables megawatt charging. If not megawatt, if the OEMs are not equipped with megawatt charging system, the batteries could accept 740 kilowatt per hour of battery capacity, which based on our calculation is only 30 minutes charging time in Vancouver or even in Delta to make it back to Kamloops, which is going to enable one of the toughest routes to be electrified. And I think that will bring along a wave of other different transportation companies gearing up to take on that challenging route. It is one of the most challenging routes to do in trucking is the line haul between Kamloops and Vancouver. And then again, to re-emphasize, if that could be electrified, the 2035 or the 2040 target for achieving 100% net zero mobility is actually quite achievable. Our hypothesis was that electric trucks can outperform diesel trucks in local delivery application to begin with, and we've certainly proven that. Kamloops gets really cold. Even this year, the lowest temperature that we witnessed for 3 days in a row was negative 28 degrees Celsius. We somehow still made it with our electric fleet of 4 transit vans and Lion 6 electric trucks. Few days we witnessed our vans coming back at 3% left on the battery, but that's again good energy management by the drivers, driving standards that still enable us to do our 150-kilometer routes. Why heavy-duty electrification? Because I think that's where the impossible lives. Just like I emphasized, Vancouver to Kamloops transportation could be electrified if the architecture is enabled by the OEMs and there's enough charging OEM companies that could provide us with megawatt charging systems or 800 amps charging system with liquid cooling capabilities in it. So what we've witnessed in our operation between electric fleet and internal combustion fleet is 42% reduction in energy costs. And then our maintenance expenses really did go down by almost 78%. Our per kilowatt charging cost was about 17 cents per kilowatt hour, which includes the demand charge, by the way, and it's not low. The demand charge is actually quite severe. Our ROI projection turned out to be faster than we initially projected, and of course that's enabled by the low carbon fuel standards imposed by the province. That's very helpful for electric fleets. And then and most of our drivers, put 94% instead of 100 because this makes more sense. 94% of our drivers, they don't want to go back to driving internal combustion engine vans or trucks. They really like the smoothness of electric vehicles. They enjoy the quiet cabins, not constant clunks of transmission. It really keeps them stuck to EVs, and it was actually quite surprising. Winter range loss, we were prepared for it. 36% of our range in terms of the vans, we lost it due to the extreme cold weather. Our payload capacity with our Class 6 trucks is 94% of what our diesel counterparts give us. Our fleet uptime was exceptional with EVs. We haven't had any major issues. Realistically, the only downtime has been tire replacements, where we had to take our fleet off the road for a couple of days, and it wasn't too bad. Regenerative braking is a miracle. In Kamloops specifically, because we've got our hills, incline and decline, and regenerative braking. We actually gain more energy than we lose going uphill because we're making frequent stops as a last mile delivery company and our last mile operations as well. And then in terms of our charging infrastructure, it is not as big as what Emterra's got. That's more like 2 megawatt charging system. We would love to have that. We've got 10 level 2 chargers, and we have solid load sharing capabilities, so we're not squeezing the grid thin. We have DC fast chargers, 150 kilowatt. That's slightly lower than what we wanted, but our grid capability only allowed us to go up to that standard. But we are exploring different ways to achieve megawatt charging systems. We're working with charging companies. I think battery energy storage system by far has been the most viable option for us to explore megawatt charging. And then, 5 to 550 kilowatt per hour we're delivering to our fleet nonstop. Some days our charging stats are over 3 megawatts, which I think is incredible. One of the best things that we actually just found out this winter was that cold is a software issue. It's not necessarily a hardware issue. If you're preconditioning your batteries before your trip starts, we find that our range drop isn't as severe as compared to putting the fleet on the road without preconditioning the batteries. The BTMS systems and the batteries, they communicate with each other, and they're constrained by the cold weather. So if we're preconditioning our batteries before the fleet hits the road, we found out that winter range loss isn't that severe. And hills, again, they're an asset, not a liability. Considering all the stops that we make coming downhill, we're getting all of our range back. So you don't get that with internal combustion engines, not at all. It's like someone's filling my fuel tank as I'm delivering. Does not happen. And charging speed is critical. I've heard a lot of companies and people saying that charging speed is not critical. It is how we manage our charging is what's critical. But as a transportation company, that is not true. Our routes are unpredictable. Sometimes maybe we have 4 routes a day that one truck needs to cover, and the other days it's only a couple routes. So having good, solid charging infrastructure would really be exponential for the operations in terms of our charging capacity. Realistically, what we've learned is we've developed our OCPP in-house. We did not use any third-party OCPP protocol to record our charging standards. And what we found out is that if you communicate with the system good enough, you could add some reinforcement learning to your charging mechanism. You could train your load sharing device to know that what time do we need to turn off the charging and what time do we need to turn it on. It creates a good algorithm for our charging system if you prefer developing it in-house than using a third-party OCPP, which I think are amazing, but for our case scenario, it really didn't work out using third-party OCPP systems. And then one of the biggest bottlenecks that we realized during our operations was the charging capacity of the Lion truck. Their batteries are designed to take 350 amps worth of charging, but their charge port was only designed to take 150 amps. So they've limited their battery capacity to 1/3 of what it could really be. So we couldn't really make sense out of that. Why would they do that? EV maintenance remains scarce. We really don't have any means of EV maintenance in the Kamloops region of British Columbia, and bringing the vehicles down to Vancouver is not easy. So it'd be really nice if there was more awareness about EV repairs and maintenance facilities to be up and coming. Our solution for that is we developed an in-house certification program for our drivers to learn how to operate EVs and how to maintain them. And then our phase 1 was 100% fleet electrification. We achieved that. Our phase 2 is grid interaction capabilities, energy generation integration, and complete operational optimization, which is that we train our systems as we grow our fleet. And our phase 3 is to have an operational hub in Vancouver equipped with megawatt level charging systems, so we could enable the line haul between Vancouver and Kamloops and have an energy positive logistics model. And of course, technology is growing by orders of magnitude every year in terms of the software availability for the EV infrastructure. And the ultimate goal for Moving Mountains Logistics stays to transform vehicles from energy consumers into energy assets. And yeah, that's it. Thank you.
Thanks, Jay. I love seeing the metrics in your presentation as well. Okay, next up we have Michael Toland, who's Manager of Engineering Operations with the District of North Vancouver. So Michael specializes in operational and asset management. He's worked a lot with their fleet on fleet efficiency, been working on EVs for quite some time now as well. So over to Michael.
Okay, yeah, I'm Michael Tolan. I'm from the District of North Vancouver. That is the neighbouring municipality to the City of North Vancouver. So just to give you an idea, what I'm going to speak about is we're running a concept trial in relation to an electric garbage truck. So we're a community of approximately 90,000, of which there's 30,000 properties, and we collect from 20,500. So we use a Mack LRE, similar to the truck that Mterra used, but we're a rear-end loader rather than an automated truck. So it's a crew of 2. It's a completely carted system, so there's nothing put in by hand. Everything is tipped using the truck. What we do is that we have 7 trucks. We collect from 4,000 houses a day. We'll go out twice a day, so we'll collect organics first, followed by garbage. So we're going out, we're collecting, we're going back to the transfer station to dump off. We're coming back out again, then we're collecting organics, coming back, and dumping off a day. So approximately 1,200 collections a day. So we worked with Mack and Pacific to obtain the truck. We started that in round about 23, received it at the end of 24, and we've been operating it from round about November on. So as you can see there, generally we start the day at 99%, and we're coming back with approximately 21% of battery life. We have come back when it's been generally colder here, as low as between 3 and 5%. We do an average distance of 62 kilometers a day. And you can see there we're tipping almost 900 carts a day, which equates to about 11 tons. And we're working for 6 hours. We don't double shift the trucks. We have 5 zones. We're very lucky. We actually surround our district surrounds the transfer station, so we don't have to do a lot of dead running. That would say for everyone is that if you're using these, is that dead running absolutely kills the batteries. So you've got to make sure you're within a distance that you're not going to run out of power. As we said there at the start there, one thing to mention as well, because hills have been mentioned here, there's a 400-meter elevation gain in the district, so we're always either going uphill or downhill. We are very, very rarely on the flat. What we've found is that we're regenerating approximately 20% of the power during the day. So generally we're using about 68 to 70% just driving around, getting there and coming back. And then we use approximately, the other 30-odd% is used either tipping carts, about 18%, and then another 18% just keeping the truck warm or cool. But then we generate 20% back. Similar to everybody else, the drivers really like them. They are super, super quiet and smooth to drive. So much so that drivers have learned they have to be extremely careful when entering and exiting intersections, because pedestrians will just step off the curb without actually realizing there's a garbage truck there. We've had people who've nearly reversed off the drive straight into the side of the truck because they just simply don't hear it outside the house. The training was pretty easy for us. We had Mack come out and do training with the drivers. They took to it pretty quickly, operationally wise. It's not that much different. The only difference is it's electric, but we do get range anxiety once that thing hits, once it hits 10%, then people are starting to ask, should I be coming back in? Am I going to get back? So for us, the next step is, this is a proof of concept. We're going to run it for a year. We haven't hit our very heavy season yet. If it works, our intention would be to replace half of our fleet with electric vehicles. The big thing we've noticed, similar to yourself, is that we could remove per truck 25,000 litres of diesel a year. We get a saving of about 60% plus. So if it works, we'll be very, very keen to get them in and working. So that's it from me. Thanks.
I have to admit, before I moved into a condo, my reminder that it was garbage day was that rumbling down the street. And so everyone will have to figure out a different kind of alarm for reminders. All right, last presenter, Tusif Warach. So Tusif is the manager of Green Fleet and Equipment with the City of Burnaby. He specializes in change management and sustainability strategies. You oversaw a huge deployment of EV charging infrastructure through the city as well, and you've been leading the Green Fleet and EV program at Burnaby. So over to you.
Thank you very much. Good morning, everyone. Thank you, Charlotte, and thank you, Zero Emission Fleet, for organizing this wonderful show and well attended. I'm honored to be part of this highly qualified panel here. So thank you very much again. So just quickly about City of Burnaby. City of Burnaby is a climate resilient city, like many others all around us. But our council has approved the climate action framework as well as the city energy strategy. And what that translates is that biggest contributors of greenhouse gas emissions, along with buildings and garbage, is our fleet. And fleet being the lowest hanging fruit, where you can use your resources and within 2 to 3 cycles you can reach your greenhouse gas emissions goals. So I think this is something that the city is actively working on. Our carbon neutral goal is for the city is 2050, which is aligned with the federal and provincial goal. And our internal goal for the civic fleet is 2040, which is very aggressive and dependent on the availability of the suitable fleet and equipment, and obviously the resources. City of Burnaby has about 1,000 pieces of fleet and equipment, over 600 being the on-road fleet. We use about 5.5 million, we have 5.5 million kilometers that we travel, using 2.5 million liters of fuel, which also includes a lot of equipment that we have that runs for many hours. So that all translates down to 6,000 or over 6,000 tons of greenhouse gas emissions that fleet produces. The City of Burnaby has been on this journey of electric transitions, especially starting in 2023. We started with the light-duty vehicles and equipment, as that is the tested and within the financial resources of the city, where we're also looking into transitioning into electric for medium and heavy-duty fleet and equipment as well. So for that, we are piloting one garbage electric truck, and we purchased 2 e-transit vans as well. Having said that, we have, are we ready for electric? Yes, we are. City of Burnaby has installed, or we will complete about 300 EV charging stations at the city, at the civic facilities, including public and civic charging stations. That will also include 6 level 3 charging stations. The rest are the level 2 charging stations. This one is the Mack electric garbage truck, the pilot that we're talking about. This is the automated arm of the for the garbage truck. Right next to the orange pylon that you can see is our portable charging, as we did not have the level 3 charging stations completed, but starting this year we'll be moving towards our own charging station. As the other participants have mentioned, it's the same capacity for the battery, 376 kilowatt. Mack provides a wonderful warranty. I'm not a salesman of Mack, but I would love the commission. But I think 8 years of garbage battery gives the confidence to purchase towards these electric garbage trucks, as they're a heavy investment into this one. We also got a bumper-to-bumper 6 years warranty, and as many of you who operate the large equipment, and especially the garbage trucks, the major expense that comes from the wear and tear of the garbage truck. So this is wonderful. Just like my panelists also have mentioned, the mileage, it really depends on the terrain and the climate. We're also completing the full full route of garbage and organics with our truck. So it's been working out so far so good, and the driver's experience is very positive. As Zachary mentioned, that once you're on this electric truck, you enjoy it so much that it's hard to go on the other side of it. These are some of the stats. So we have, in the last 3 to 4 months, this garbage truck has run about 827 kilometers. Our PTO is 21%. Auxiliary, which is more of a HVAC, your heating and cooling of the cabin and the battery, is at 25%. We think it's on the higher end of it, and we know that the technology will work on it to reduce that 25%. Propulsion, just going up and down, that's 54%. And the regen that goes back to the battery is 17%. So this is where we can use the training of drivers and smart routing for to gain maximum. I'm assuming you can actually gain somewhere between 25% or 30% if you really have that terrain and the climate for it. A couple of things that our drivers have noted, that there's a little bit of a lag that they're noticing when they press the so-called gas. It gives you a couple of seconds, and that is something that we wanted Mac to work on it. We're working with Mac to, and hopefully that will be resolved. But other than that, I think it's all in all is a positive experience. One word of advice that I got from somebody was that because it takes auxiliary 25%, that is your heating of the cabin. So do that while you have it still on charge. That'll you can have a lot more battery for that. Thank you very much.
Thank you. We're going to have to work on using gas versus accelerator pedal now. All these other little pieces in the language that doesn't quite apply to the electric vehicle world. And we're seeing it when it comes to language. The same thing can be said for the fleet world and the utility world, because oftentimes the same word means something very different for those two different industries. Great presentations. Thanks so much for sharing that. We will have some time for audience questions. I do want to start with a question of my own. So from my experience, and I think I've seen this with your examples as well, to make these types of projects work, it really takes an internal champion to take hold of this and move it forward, but it can't be done alone. And there's going to be internal and external stakeholders that have to kind of come along, either via buy-in or be collaborative partners in the project. I'm curious to hear from each of you. Was it hard? I heard some positive things regarding the drivers. I'm curious to know if it was hard initially to get their buy-in, but who were the other stakeholders that really were key to making these projects successful? Maybe we'll start with you, Tosif.
Yeah, thanks very much. And so for any city, for a municipal government, obviously you need the positive intent from your higher management and the council, which we were very lucky that we got it. But then again, the overall cost of these, for example, garbage truck and transitioning into it, a regular diesel truck is around $550,000 as compared to electric, which is almost double. So unless you have a funding program that we're thankful to, the federal and provincial funding, that is almost $300,000, that really helped us making that decision. But talking about the full fleet and talking about the light duty, medium duty, and heavy duty fleet, City of Burnaby having 1,000 pieces of it, you got to have a good study to ensure that there's a cost-benefit analysis to it that you can prove on to the public that this is why we're doing what we're doing. But this funding really helped us.
Very similar from a municipality, so buy-in from council and executive. We had a lot of help from Mac, who helped us with this. We use a bit of a different method. If we're buying anything that's alternatively fueled or considering it, we will always lease them first, and we'll run a proof of concept trial. So we'll make sure it works, because we have, for example, we've trialed recently road sweepers that are electric, but we found out they can't do our duty cycle, so we won't progress with them until the technology's there. So it's similar here. We want to make sure that technology works, it can do the duty cycles, and then we would move on.
That was a really good elaboration on how the stakeholder works, the partnerships with the federal and the provincial incentives. Certainly for us, it would have been impossible if those incentives were not in place to really take on this journey to electrify medium heavy duty transportation, freight transportation. Being a private company, we really don't have deep pockets like the municipality does. So there's a lot of internal discussions that takes place with the CFO and our staff as well in terms of what works and what does not. The dealerships as well as the OEMs are very transparent too about the performance of their truck. We've seen instances where OEMs increase our expectations by tenfold, but the product under-delivers, which is the EV trucks for us. The Lion 6 trucks that we acquired last year, the cost, the MSRP was about $350,000 per unit, but the federal and the provincial funding combined brings that cost down to about $150,000, which is still comparatively expensive than an internal combustion engine. But then you have the internal discussions about, okay, what can we project with the BC LCFS credits with our consumption? Does it make sense? Does it not make sense? But in our case, it really did make sense. Well, being a private corporation, the first pain threshold is always the cost of equipment, not necessarily, well, yes, the performance as well, but the cost outweighs the performance. But yeah, having those conversations, even with, what I found out is Plug-in BC's staff is just awesome to work with. They're very transparent, and they're very open about the communications, and yeah, that was very helpful.
Thank you. Yeah, I'd have to agree with everyone here. First and foremost is pricing. So the grants, without them from BC Hydro, from Plug-in BC, federal, provincial, currently you just can't make up that cost internally. For the buy-in, it's everybody, you need to know it works before you buy it, which is very helpful with Mac. And you test out a truck, you run your routes, you see if it works for your operations before you throw yourself in the deep end. Last thing I just want to touch on is infrastructure, really. You can have the vehicle that works, you can have the equipment that works, but if you can't charge it, you can't run it. And that's where it really helped with BC Hydro, is talking with them, discussing with them, with infrastructure-wise, how much power do you need? Can you upgrade it? When do you charge it? What can their grid support? And their help with that, it was very key, as well as, of course, the fundings.
Thanks. Do we have any questions from the audience? Yep, in the back with that. Yep.
Hi there. I was just wondering if your company's facilities had adequate electrical capacity to install the infrastructure, or if you had to bring in a new service from BC Hydro, and what were some of the challenges with that, or how hard or easy was it to get that EV charging infrastructure installed?
I guess I'll take it. So at our existing site in Cumberland with our 8 trucks there, initially, if you look at it, with our existing power consumption, and then if you just simply tack on those extra trucks, we didn't have enough power. So the initial thought was, okay, we need a power upgrade. But looking a little further, we looked at when are we actually charging these trucks. In the day, when we're running our plant, they're in operation, they're collecting. So we don't need to charge the trucks at that time. When they come in at night, our operation's complete, then we still have the power now available at that point to charge our trucks. So we can do an overnight charge, and during the day, when they're out collecting, we can run our plant operations as is. So what we did is the power management system. If a truck comes in early, we can plug it in, but it won't allow a full charge, so it won't blow our grid. Of course, if you want to expand, if we wanted to put in 10, 15 trucks, yes, you need the power upgrade on our site. So essentially, we didn't have to do a power upgrade at the time because we were able to work around it with the charge management system. But for large fleets, you're gonna have to look a little closer on what kind of upgrades are available in the area.
Just to add to your answer too, we actually lucked out. Moving Mountains Logistics, when we were first scaling up our charging infrastructure, we were also, our lease was about to run out at our existing facility, so we were looking for a new facility. We got lucky and we got into a building that had a 6 megawatt customer-owned substation. So that for us was like, whoa, that's a gold mine. Now the constraints from BC Hydros are gonna go down, and we have more than enough power available to implement megawatt charging system. So as soon as we saw that 6 megawatt substation, we were like, okay, that's it. We're locking it down.
I would just say for ourselves, that's going to be our limiting factor. We're in an area where the electrical capacity is almost maxed out. So at the minute, we've got enough to charge one truck. If we're going to decide to move on, that's going to be a big challenge for us.
So City of Burnaby, we as I mentioned, we got 300 EV charging stations, but there are different sites. So the transformers are different. One of the sites, just like Mike mentioned, we have a total capacity of certain level 2 charges or even level 3 charges that you can simultaneously charge everything at. So you have to have a power management to ensure what vehicles or equipment will be charged at what time and how much before you go to the next one.
Thanks. We have time for one quick question. Not everyone can answer this, so yes, go ahead.
So yeah, you're looking at the restrictions from the grid. Is there anybody who's able to lease you a battery storage system so you can maximize that feed from the grid all day, make sure that's all popped up so when you do need to use your vehicles, that's there. So are there companies out there providing that to you?
So the question is battery storage, on-site storage.
Yes, so as I mentioned, we think that'll be a limiting factor. So we do know now there's products on the market which you can charge during the day. And then when you bring your trucks in, you can discharge back into your trucks. So that's something we might consider if and when we decide to move forward.
I don't know about leasing, but there's certainly companies that offer this. And what we've seen from some of our customers, there's a combination of some are using temporary chargers. So in the case where it's a long wait time for kind of back-end infrastructure upgrades with their utility, then they're using kind of temporary chargers with battery storage to do that. Some are setting up solar panel array and site storage that's permanent at their sites. So there are many different models that we're starting to see. Just
wanted to add one comment that I think it's more of a cost. It's very costly even if you have those systems. We have solar panels, and we are not able to. The cost-benefit analysis didn't really work out. So you have to get the solar energy and put it back into the system, and then get it again.
Just one last comment on that. We're starting to see more of a model for fleets, particularly if they don't own, if they lease their facility or if they have capacity restrictions. The depot as a service or charging as a service model is starting to pick up, where maybe the charging infrastructure isn't actually located at their facility, but it might be off-site, and it could be shared with other fleets as well. So there's a lot of interesting new business models that are kind of flipping how fleets are thinking about their vehicles, how they're thinking about their charging, and switching from an upfront capital cost over to kind of an as-a-service cost as well. With that, I think we are about to break for lunch. Does anyone, I'd just like to ask our panel if anyone has any words of wisdom, quick, like 30-second word of wisdom to share with a fleet who's just getting started on, what to avoid or what to look out for. Anyone want to go?
I would say make sure you've got your charging capacity before you dive in.
Anyone else?
Yeah, I just agree. You can have all the equipment that works, but you need enough power to be able to charge it.
I'd say choose the right OEM. That's the biggest challenge.
Yeah, I think for medium and heavy duty, there's so much that is happening, and I think electric is a one way to go. I'm not sure, if there are other technologies they will be available. So I guess depending on your organization, how you want to extrapolate your own data to look into next 10 to 20 years. for the zero emissions and what qualifies for your equipment. But medium and heavy duty, that the pace that we were expecting to have. So, for example, your backhoes, your loaders, they cannot work for 8 hours straight with the battery for now. So you can't really, go and buy them right away, especially if you're in the local government settings type of thing. So I think the technology, there's a lot to be had. I think in the next 4 or 5 years or 10 years that we will experience. So do your math right before you convert anything to whatever you want to convert to, because it's very expensive.
Great. If folks have more questions for these panelists, I'm sure they're hanging around for lunch, so find them, ask your questions. And with that, please join me in thanking our panel.
Make sure to subscribe to our channel for more updates on fleet electrification and other sustainable transportation solutions. Thanks for watching the Go Electric Fleet Show.